back over to the very first one and ignore my graphs on the board, okay? You don't have all of that. All you should have is this blue triangle. Is that what yours looks like? Okay, so the first thing is, it says apply the transformation. I'm going to say this a couple of times today. If you're not listening, you will miss points on the homework. Every single time you see this word apply, you are going to think to yourself, graph. If it says apply the transformation, that means I expect you to graph the transformation. Okay? Write it down on your notes. Get it in your mind. Apply means graph so that you don't miss points on the homework. So it says apply the transformation to the polygon with the given vertices. Identify and describe the transformation. So the first thing you're going to do is graph the original points, which you already did on your graph paper. And then you're going to apply this transformation and graph it as well. And then you're going to identify and describe it. This one you should have known the moment you looked at it what transformation this is just by looking at the rule. What is this transformation? It's a translation. Without graphing it, you should already know this is a translation because we learned it in chapter 1. And what is the translation going to do? What's the description? Left 4, up 1. So you're going to say translation, left 4, up 1. That's your description. So you identified and described it. Okay, you do not need the graph to know that right now. You should be able to look at the rule and automatically know that. By the end of the day today, you should be able to recognize by any rule what the transformation would be without having to graph it. But you are going to graph it because if it says apply, then I'm going to be grading for your graph. Okay, so you're going to apply the transformation. We graphed the blue triangle already. Now we want to graph the new red triangle. The easiest way, I think, to graph it is to just shift your points left 4, up 1. Would you guys agree? So go ahead and do that. Shift them left 4, up 1. And then make sure that you label with correct prime notation. P prime, Q prime, R prime. Just like we did in chapter 1. And this one should have been complete review. Agreed? Okay, I'm going to give you a minute to go ahead and graph that triangle. Make sure that you've got it labeled good. You also may want to write at the top of your graph paper 4.1 notes, because if you go home and try to look back at your notes, you may be really confused by the fact there's nothing on your paper. And you're like, what did we do when we did this by the time we get to section 9 and you've forgotten about today? So it might help you to organize this graph paper with your notes, okay? Okay, moving on to the next one. So this one we have not talked about. What is this going to be? After today, you need to be able to recognize just by looking at the rule. Okay, so you think it's a reflection because you're seeing my picture. But if you don't have this picture, you need to be able to look at this and know what it is. Okay, so we're going to get there. But right now, when you're working your problems, forget about my graph. If you aren't sure, you get to the homework and you're like, man, I don't know what it is. Then you can calculate your new coordinates by using your rule. So let's do it that way first, just in case you find yourself in that scenario. So if I want to find A prime, I'm going to put 1 in for X and 2 in for Y. So what are my new values going to be for A prime? 1, negative 2. Okay, for B prime, we're going to plug the 4 in for X, the 2 in for negative Y. We get what? 4, negative 2. And then C prime. 3, negative 1. Everybody with me? Javi? Okay, so we talked about that last in chapter 1 as well. We said that if it was to reflect across the line like y equals 1, then you say it's a reflection across the horizontal line. The rule will always, oh, good question. You can only write a rule if it's going across the x-axis or across the y-axis for this lesson, okay, for what we're doing right now. So I love that. So you wouldn't be able to write a rule if it was across something else. Okay, if you are able to write a rule, then it's only going to be across one of your axes. I gotcha. Okay, so then go ahead on your graph paper, graph those points. And label them A prime, B prime, C prime. And I'm going to start a little list over here on the board of things we've learned so far. Oops. Okay, so far when you walked in here today, you should have already known that if it is in this form, x, y, arrow, x plus a, y plus b, that's a translation, and you're going left or right a, depending on if it's a plus or a minus, and you're going up or down b, right? Everybody with me? Okay, and just now you just discovered that this is what again? What transformation? Reflection. So remember it said to apply the transformation, which is the graph. So you'll get points for having it graphed correctly, labeled correctly. Make sure you're connecting your dots and drawing lines. I don't know why, but every year somebody doesn't do that. So connect your dots. It's a reflection, and then be specific from chapter 1. Across what? Careful. X-axis. So reflection across the X-axis, and make sure I can tell that that is an X and not a Y. If I can't tell and it looks like it could be either one, then I'll count off. Okay, so reflection across the X-axis. So what you just learned is that if XY maps onto X negative Y, it's going to be a reflection across the X-axis. Think about why that is. If you go across the X-axis, which value is changing from positive to negative? The Y. So Y is going from positive to negative, which means you're going to reflect across the other variable's axis. Does that make sense? So if that's the case, what would a reflection across the Y-axis have to look like as a rule? Say it again. Very good. So another one we could list here is X, Y arrow. The X changes to a negative, but the Y stays positive. That's going to be a reflection. But that will be across the Y-axis. Because if I go across the Y, I'm going from positive X to negative X. Does that make sense? So whichever one is changing to a negative, it's the other axis that you're going to reflect across. You're going from positive X across the Y to a negative X. Everybody with me? So again, at the end of the day today, you should be able to look at the rule and automatically be able to say, this is a reflection across X, this is a reflection across Y, this is a translation. Okay? So if you look at C, C is different. C does have one of them changing to a negative, but what has it also done to the X and the Y? Switched them. Okay, so now we need to discover what that is. And again, if you don't have a graph, then you're going to use the rule to come up with what are my coordinates. So again, I want you to pretend that you can't see that picture, because some of you will get to the test or the homework and you may forget. And the easiest way to do it then is to plug them into the rule and come up with your new coordinates. So let's find R prime. Keep in mind that the Y is going first and the X is going second, and the X is changing sign. So that means, what are we plugging in for Y? 0. And what's going in for X? -3. And when we do a negative, it becomes a positive. So what is R prime? 0, +3. Is everybody with me on what? So we're switching them and we're changing the sign of that second one. So what is E prime going to be? So again, the Y goes in for Y, so it's going to be 3. The -3 goes in for X, but it's also a negative, so it becomes a positive. So it should be 3, 3. Okay, how about C prime? 3, 1. And then T prime. Good. 0, 1. Are you guys with me that we are switching them and then changing the sign of that second one? Okay, so then we graph it. So take a minute, graph it on your paper, label it R prime, E prime, C prime, T prime. And then now we need to identify and describe our transformation. That was also part of the directions. Bless you. So we're going from blue to red here. What transformation do we have? It's a rotation. What direction? Clockwise. How far? 90 degrees. And what is our center? About the origin. So these were all the things back in chapter 1 that we had to write when we were doing our work, correct? So we're going to talk about that in just a second. But is everybody with me? This would be 90 clockwise. We're good here? And remember the little trick if you forget? Go from the origin to one of your pre-image points and then one of your image points. And that forms your angle of rotation. So that also helps me see that it's 90 degrees. Okay? You could have said 270 counterclockwise as well when you described it, and that would have been correct. Okay, so I'm going to write it down over here on what we've discovered. So number 4, XY arrow. If I want to do a 90-degree rotation clockwise, I switch the Y and the X, and the X changes to a negative. That is a rotation 90 degrees clockwise. Okay, I want you to think about that graphically and see if this will help you come up with going the other direction. So if I'm going clockwise 90 degrees, if I have a point right here, X, Y, anytime you rotate, you're going to switch your X and your Y. Anytime. So this is going to become YX. If I'm rotating 90 degrees clockwise, I'm rotating to the right. I'm going from a positive XY down here in the second quadrant, or fourth quadrant, sorry, where what coordinate has a negative value down here? The second Y value, right? Take away the letters X and Y, but it is the second coordinate in this parentheses that is negative, right? So that is why we change the sign to a negative. Here is how I memorize it. If I am going to the right, I change the sign on the right. And that will help me remember. Always switch if it's a rotation. So if I'm rotating clockwise to the right, the one on the right changes sign. You always switch your X and Y. So if we apply that, let's go the other direction counterclockwise, 90 degrees. Instead of being XY, we're going to switch it, YX, and now the Y is going to become a negative because we're going to the left, so the one on the left changes sign. Or when you rotate counterclockwise, you're going from where X was positive to where X is now negative, and the first coordinate is your X term. Does that make sense? So the way I remember it is if I'm going clockwise to the right, switch and change the one on the right. If I'm going counterclockwise to the left, switch and change the one on the left. So our next rule we could write down, which Javi asked, what about if we're going other directions or other amounts, like 180, 270, right? So XY arrow, it'll be negative Y, positive X, if we are rotating 90 degrees counterclockwise. Everybody's okay with that so far? Okay, now I want us to investigate what happens to get to 180. So I'm going to come over here and I'm going to make a little chart for both rotations so you can see what happens. If I were you, I might write this down somewhere on the back of my notes where I have some room. So if I'm going clockwise versus counterclockwise. Okay, clockwise means that I'm rotating to the right. Okay? Counterclockwise means I'm rotating to the left. Agreed? Okay, so we just said if you're doing any kind of rotation, you're going to always switch the X and the Y, and one of the signs are going to change, either the one on the right or the one on the left. So if I'm doing a 90-degree clockwise rotation, we said XY will become switch YX. Clockwise is to the right, so it's Y negative X. I don't want to go too fast because I want to make sure you're with me in the thought process too. So now if I want to do 180 degrees, that means I'm going to take my 90-degree rotation and do it again, right? So it's still going to start x comma y because you always start with your original. But now we're going to switch these coordinates again because we've already switched them once for 90. We want to do it again for another 90. So switch them and then change the sign on the right. So if I switch them, I get negative x comma positive y. And then I change the sign on the right. Say it again. A clockwise rotation of 90 degrees takes your coordinates and switches them and changes the sign on the right. If you want to do 180, then you have to take those coordinates and do it again another 90 degrees, switch them, and change the sign on the right. For real, are you with me?
Yes.
Okay, let's go to counterclockwise and see what happens. So should it make a difference if I go 180 degrees, which direction I go? It shouldn't make a difference. 90 does make a difference, but 180, you should end the same location whether you're going clockwise or counterclockwise. So let's do 90 counter. So we just said over there on the board, if I'm going counterclockwise, that's to the left. So XY is going to switch, YX, but we're going to change the sign on the left. So 180 means we should do that same thing again to the coordinates we have after our 90-degree rotation. So we'll start with our original coordinates, x, y, and if we're doing a full 180, they should land on, switch them, you get x, negative y, but then you change the sign on the left, and we get negative x, negative y. So you get the same thing for 180 degrees. So notice if only one variable changes sign, it's a reflection, either across the x-axis or across the y-axis. But if they both change sign, x, y arrow, to negative x, negative y, then you've done a rotation. You've actually done two reflections, but one single rotation. And that rotation is 180 degrees. And the direction does not matter. So you don't have to tell me clockwise or counterclockwise because it wouldn't matter. 180 degrees. About the origin. And again, none of these rules can be written if you're not rotating about the origin or reflecting across an axis. Translations left, right, up, down are always going to happen, but translations don't have anything to do with the origin because it's going to be left, right, up, down. So you could do a translation and then write a rule from there, but we're not going to do it that way. Okay, but yes, you could. Is everybody okay with me here? Okay, let's look and see what happens when we go one more time 270. So a 270 clockwise should be the same as what? 90 counter, right? So let's see if we get the same thing if we do this one more time. So 270 degrees, X, Y, arrow. If you're going 270, that means you switched it once, you switched it twice, and now you're going to switch it one more time. So you're going to switch the coordinates, negative y, negative x, but you're going to change the sign on the right. So you get negative y, positive x. And is that the same thing as what we have here? Yes. So a 90-degree counterclockwise rotation would be exactly the same as a 270 clockwise rotation. So if we did the counterclockwise one more time, 270, X, Y arrow. We switched them once and changed the sign on the left. We switched them again and changed the sign on the left. We would do it a third time, negative Y, negative X, but we would change the sign on the left so that it's positive Y, negative X. And do you see that you get the same thing as the 90 clockwise? And what should we get on either one of these if we switched them one more time? We should be back to where we started. So do you agree if I switch these and change the sign on the right that it's going to be XY? And if I switch these and change the sign on the left, it's going to be positive XY? Okay. So the three that you really need to memorize are listed over here. Because as long as you recognize this is a rotation 90 degrees clockwise, you don't need to write 270 counterclockwise, right? You just need to know one of them. So always switch. If you see they've switched, that's a rotation. Whichever one changes sign tells you the direction. If it's the one on the right, you went clockwise. If it's the one on the left, you went counterclockwise. If they both change sign, they've switched twice, so they didn't look like they switched at all. If they both change sign, it's a rotation 180. Are we good with it? Okay, last one on your paper. D. So when you see this, this is your final transformation. We have taken each coordinate and we're multiplying it by a scale factor. We said at the very beginning of the notes that this is what transformation? Dilation. Dilation. Yes, dilation. Okay? Remember when you tell me it's a dilation, you have to tell me either an enlargement or a reduction. If the number you're multiplying by is greater than 1, it is what? Enlargement. So this is a dilation, enlargement by a factor of 3. Or you could even say by 3. I would accept that. You wouldn't have two different factors. You cannot take a shape and you can, but a true dilation increases the entire shape by the same factor, okay? So it would not be written that way. Okay, and then all you have on your paper is the little blue triangle. So the way you could find your new coordinates to increase or dilate it by a factor of 3 is just to multiply every one of these coordinates by what? 3. So to find K prime, we're going to multiply it by 3 and we're going to get what?
-6, -3.
Perfect. -6, -3. L prime?
3, -3.
3, -3. And N prime?
3, -6.
3, -6. And then I want to warn you. Yes, ma'am, go ahead. I'm not sure what you mean by 1, 2, 3, 1, 2, 3. But the slope from here to here is not 3. There's, you're going right 2, down 2 to get here. So I don't think that'll work. Okay. You can do, from the origin, you could do, you could say that you're going to multiply the distance by 3. So like if I went right 1, down 1 to get to here, then I'm going to go right 3, down 3 to get to here. You could multiply your slope by a factor of 3. Here I would go left 2, down 1. So then means I'm going to have to multiply that by 3 to get left 6, down 3. Does that make sense, Ridley? Does everybody else see that? If you do it from the origin, because it's a rule, it's always done from the origin, and then what you're doing is multiplying your slope by that factor to get your coordinates. Okay? So same thing here. I could go right 1, down 2, which means I'm going to go right 3, down 6 to get my new one. Yes. Also notice, if you're not sure where your center is, you can always connect your pre-image to your image point. Draw this on your paper so you can see this. Your pre-image to your image point, pre-image to your image point, and wherever they intersect, that's the center of your dilation. If you connect pre-image to image, pre-image to image, pre-image to image, and draw lines, wherever those 3 lines intersect will be the center of your dilation. We already know it's the origin because they gave us a rule. If they hadn't given us a rule, it may not be the origin, and you may have to find where it is. It will always give you where the center is. You just can't write a rule unless your center is the origin. Okay, or unless you did what Javi said and translate it first to the origin and then do it. Okay, questions? Trying to think if I've forgotten to tell you anything that might be important. I don't think so. Okay. So here's the chart where everything we listed on the board is. I know I had you write it down, or you may have written it down with me, but here it is. Yeah, you didn't have to, but it's good because writing and thinking and listening, it all helps you memorize. All right, last few things here. So isometry, definition. An isometry is a transformation that preserves your length, your angle measure, and your area. In other words, an isometry keeps your shape congruent to its original size. So it produces an image that is congruent to the pre-image. So very good. What is the only transformation today that is not an isometry? So everything except a dilation. Not a dilation. Okay? A rigid transformation is just another name for an isometry. So again, every one of our transformations is rigid and is an isometry except the dilation. Dilation is not a rigid transformation and it is not an isometry. Yes, both of them will be on the vocab test, and so the one that says another name for isometry is not isometry. It is rigid transformation. So a dilation is not an isometry, and it is not a rigid transformation. Say it again. Okay. All right. This is where it just said the same thing you just told me. Translations, reflections, and rotations produce images that are congruent. Dilations produce images that are not congruent. Okay, so there's two examples left in your notes that we need to practice. So the first one here, determine whether the polygons with the given vertices are congruent. It is different than, I want you to skip ahead and find the next set of directions. So we're not going to do all of these examples that are left. There's a lot of examples, but they're all the same. It's just different pictures, okay? So I'm going too fast. Find the one here that changes the directions and says, prove. Okay, remember, we're not doing two-column proofs today. What did I tell you that the way we're proving shapes congruent is today? By transformations. We're using transformations. I went too far. Hold on. Let me go back. Come on. Okay, guys, go ahead while you're waiting on me and graph. Can I borrow this real fast? Edwin, you with me? Graph the example 2, where it says determine whether the figures are congruent. Example 2, and then as soon as you get those two shapes graphed, flip it over to example 3 and graph the one that says prove the polygons with the given vertices are congruent. Okay, so example 2 and example 3. Example 2 and example 3, not check it out. Example 2, example 3. Go ahead on 2 different graphs and graph those shapes. And I'll pull this back up. Example 2, example 3. Example 2 and example 3. Should say example 2 on it. Does it say example 2? Okay. Because the next one says, do they all say example 2? Example 2, not the one that says continued and not the check it out example 2. The one that says example 2. Okay, this one right here. Okay, just example 2. So quickly fix it. Example 2, and then go to where it says example 3. Not continued, not check it out, just example 3. Graph the two shapes so that we can talk about them. The first one on the back is the next one that you're graphing. It's the second shape, yes. They're not using the same letters. They're telling you you have this shape and you have this shape, and you're deciding. They're not going to call them primes when they're giving you two different shapes and asking you to decide. Okay. We're going to get there in just a second. The first one on the back. Yes. Not the check it out. Say it again. We will, yes. Okay, raise your hand if you need more time to graph example 2. If you're not done with example 3, that's okay. We'll come back to it. Okay, example 2. So it says determine whether the polygons with the given vertices are congruent. I want to stress the difference in the directions. This says determine if they're congruent, which means you could have an answer of no or yes. Now, if you look at example 3's directions say what? Prove that they are congruent, right? So can you have no as an answer? No, they're not saying are they congruent. They're saying they are. You need to prove it, okay? So there's a difference there. If they're congruent, should they be a dilation? No. So if it's gotten bigger or smaller, then the answer is no, they're not congruent. If they look to be the same size, then your answer is yes. And either way, you've got to tell me what transformation it is. So when you look at this, do you think that they look like they're the same size? Okay, so we're going to say yes, they're congruent. And then we're going to list the transformation as a rule that would get us from the first one. Let's stick with first to second so that it's easier to compare answers. It wouldn't be wrong if you did second to first, but it's going to help if we're all checking our answers. And if you look in the back of the book to see what they put, they're going to go from the first one to the second one. Okay, so whichever one that's named first, let's call that our pre-image, and whichever one's named second is the image. So we want to go from blue onto red. What transformation do you think takes you there? Translation, so you think it's a translation. What directions and how far? Okay, so I heard left 1 and down 3, right? So left 1, down 3. So now let's write a rule that says that. X, Y, arrow, what? X minus 1, comma, Y minus 3. So yes, it is because this is the information that proves it. When it says prove it, that's all you're doing. You're just writing a rule describing your transformation. You don't have to do both, but if you want to really think of homework as the practice for the test, sometimes I'm going to ask you to write a rule, sometimes I'm going to ask you to describe. It would be better to do both, and then you're practicing that every time. Okay? No, you have to give me the transformation. You do have to back it up, but you could just describe it or just write the rule.
So you could just put yes, that,
Or this. Yes. Okay. Well, this says determine, but I expect you to back it up either way. Okay? So let's skip on to prove. Prove means you don't have a no. Prove means it's definitely congruent. Now mine doesn't look like they're congruent, does it? That is why it is always bad to create your own graph, because they did not use the same width for their x distance of 1 as they did for their y distance of 1, right? And what did that do to the graph? It distorted it, right? So you should never ever change your scale. You should always use a good graph that's already made for you. So mine doesn't look like it, but when you look at yours that you graphed, does it look congruent? Yes. Okay, so if you haven't finished graphing, graph that real quick. They do look to be congruent, and we know they're congruent because it said prove. So what you have to do is you have to list the transformation or transformations. It may be more than one. That takes, again, let's go first to second. That way we're all consistently having the same answer. So we want to go from the blue and make it land on the red. Sometimes it's going to take more than one transformation. Sometimes it's just one transformation. What transformation do you think for sure we have to do here? Rotation, okay? I would agree that it looks like we have to rotate it. What direction? Counterclockwise. How far? 90 degrees. Okay, so let's start and say I think that it is a rotation 90 degrees counterclockwise. About 0, 0. Let's go ahead and write that as a rule. So that would be x, comma, y, arrow, rotation switch, y, comma, x. If we're going counterclockwise, that's to the left, which means we're going to change the sign on the left. So it's negative yx. Okay, but now you have to check and see if that works. So I'm going to graph the new shape after I rotate it, which means all of these blue coordinates should switch and change the sign on the left. So where is A prime going to be now if I switch and change the sign on the left? Negative 2, 1. Where's B prime? Negative 1, 2. Where is C prime? Negative 2, 4. Are those the coordinates that I have over here? No. So that means we need to graph this green shape and see, is there another transformation after I rotate it that will make the green one land on the red one? So I'm going to graph these points. Negative 2, 1. Negative 1, 2. And negative 2, 4. So, or yes, negative 2, positive 4. Which is going to go off my graph up here. So this was A prime, B prime, C prime, right?
Yes.
You guys agree? So graph it on yours, look at it. What are we going to have to do to get the green to land on the red? Translation. So now there's a second transformation.
So would you put, would you be like 1, is that, and then 2?
Yeah, you would list them both. Translation, what directions, how far? Hold on. Left 1.
Down
Left 1 down 3, right? So translation, left 1 down 3. So you may have a different translation depending, Javi, the order won't necessarily matter. You just need to make sure that what you write works. For me personally, I have never been able to translate it before I rotate it. I can't visually see that. If I know it has to be a rotation, I have to rotate it first. Then I can easily see my translation. But for whatever reason, my brain cannot say, oh, I need to slide this left 1 down 3 and then rotate it. I can't do it. But maybe you can. And so if you can, then you could switch your order. Okay? But I can't. If I have a rotation in the process, I got to rotate it first. Okay, here's the only extra thing I want to add here to the notes, and then we're done. When you write your rule, if there are multiple transformations, you do not write multiple rules. You are not taking the blue coordinates and rotating them and then going back to the blue coordinates and translating them, right? You're taking the blue coordinates and rotating them and getting these green coordinates, and then you're taking those coordinates and translating them. So you should have a continuous rule. Does that make sense? So xy is going to map onto negative yx when we rotate, and then those coordinates are going to map onto x minus 1, comma, y minus 3.
Oh my.
Are you guys with me? If you have multiple transformations, you write a long rule. Okay, not separate rules. All right, and that is all there is.
Is it hard?
This isn't near